Sounds good. So let's do B. So we did A. This was F and G, and we did F G prime plus GF prime. Let's do B. So they say let y equal u times v, where u and v are going to be functions, just like F. They could have said F and G. So u and v are just functions. Find y prime of 2. So let me just stop there before I look at the other given information. This says find the derivative of y prime and then plug in 2. Okay, that's what it says. So before I even look at this, is the information we know. I can already just look here, and I can do y prime. So I'm going to look at this and just do y prime. Then I'll plug in the values that I need. So y prime, I have to use the product rule. Since u and v, I really should have put on here, u and v are functions. I should be more specific. Okay, so u and v are functions, and I need to do the product rule. So I'm going to do the first function, u, times the second derivative, v prime, plus the second, which is v, second function, times the first derivative, which is u prime. Now, it could have told us, like, hey, the function u is 2x, and the function v is something else, like 3x squared. And then we could just work it out. I could have actually plugged these in and found the derivatives. But they didn't even give us the functions. All they gave us is the values of functions at 2 prime, the derivative of 2, derivative at 2, v at 2, and v prime at 2. And that's all we have down here, so it kind of works out. So to get y prime of 2, I just need to plug in 2 for all of these. So I'll write it out here. I'm just going to do u of 2 times v prime of 2 plus v of 2 times u prime of 2. And all that information was given here. Okay, so I'm just going to plug in u of 2 is 3 times v prime of 2 is 2 plus v of 2 is 1 times u prime of 2 is negative 4. Yeah. And so we get 6 minus 4, which is 2. So, the most common error I see of these types of questions is students just say, they say the derivative is u prime v prime. And so they plug in u prime of 2 is negative 4, and v prime of 2 is 2, and they say it's negative 8. Because they think, like, the sum and difference rule, you can just do, if you're adding derivatives, you can just do them separately. If you're multiplying functions, the derivative, you can't just do the individual derivatives. You have to do the product rule, work it out, and then plug it in. All right. I'm going to go on to quotient rule, last rule. Any other thoughts on product rule? And again, I want to mention, this rule works if you can choose any 2 functions. Like, you could choose 2 as your f, but only do it, like here you wouldn't need to. You could just do a normal power rule. So I wouldn't suggest this. Only do it when you have functions. One is x squared and the other is e to the x. I mean, we don't know that yet, but okay. So let's do some quotient rule. I'll tell you, I always power and product and quotient. I just always mix up I know which one I'm using. I just always mix up the words when I say it. So we did product when you're multiplying 2 functions. So that naturally brings up the question, what if you're dividing 2 functions? X squared minus 1 divided by x squared plus 1. What's the derivative of that function? You have to do the quotient rule. Anytime there's a quotient, there's a fraction. There's kind of one exception I'll show you down here. But this one is going to look pretty similar to the last one, but it does have a denominator. Okay? So the derivative of f and g are your functions, and the f is numerator, g is denominator. The derivative will be gf prime minus fg prime just the numerator. Does that look pretty similar to the last one, the product rule? The product rule was just f g prime plus g f prime. So if you, bless you. So, I mean, it has the exact same values here. It's just they're reversed, and that this one has a negative. So this is how it's usually written, but you actually could just do it as the normal product rule and put a negative in front of the first one. And then it would be the same as this. And then it's all over g squared. Not g prime, just g squared. So there's a little memory tool, I guess, that I've always heard, yeah, I've checked with some other calculus teachers, they always heard this too. For the quotient rule, the rule is this: low d high minus high d low, all over low low, or you could say rho squared. So yeah, it probably sounds a little crazy. Low d high. So this is the low function, the g, and the high function is the f. So that helps, if it helps you remember, low d high minus high d low, all over low low. But what I mean by that is low times low would be low squared, so g squared. Or you can just say low squared. The other thing is you could just remember, hey, it's the product rule. Actually, as I'm thinking about it, this might be the easier one. Just say, hey, it's the product rule. You put a negative in front, and you just put a g squared on the bottom. Might be the easiest one. I might do that here. All right, so that's quotient rule. Okay, let me try one out. Find the differentiate. Find the derivative of this function. So h prime of x. Let's see. Trying to think which one I should do. Let's just do how it's traditionally written. Let's do this. So gf prime. So low d high, where this is my g, and x squared minus 1 is my f. So it's low x squared plus 1 d high. So I put in parentheses, and then I times it by my high derivative. Derivative of x squared is 2x. Derivative of negative 1 is 0. So I'm not going to write that deeper. Minus fg prime, so I'm right here, high d low. So the high function is x squared minus 1 in parentheses. And the low derivative, so g prime, derivative of x squared is 2x. And the derivative of 1 is 0. And then you just put it over your low function squared. So, you know, let me write that. So this was g f prime, this was f g prime, and then that was g squared. So then we're going to simplify. Guys, you always want the most compact. Because what we're looking for is, like, soon we'll do a tangent line. Something with instantaneous rate of change. So we don't want it to be expanded too much. We're going to plug in a lot. So you never have to foil something like this on bottom. You want it as compact as possible. So I really just need to simplify the numerator. So that's what I'm going to do. So I'm just going to distribute the 2x here and here. So first one will have 2x squared x cubed. 2x times 1 is 2x. Okay, now over here, it's minus whatever I get. So again, I've said before, this is one of the most common errors. Is students do not distribute that negative. So let me first put in the 2x. So 2x times x squared is 2x cubed. And 2x times negative 1 is negative 2x. And now I just rewrite the bottom. So why don't I just simplify this negative over here. If I distribute the negative, this one will be negative, right, and this one will be positive. And so finally, this should be my simplified final answer right there. I have 2x cubed and negative 2x cubed, so those cancel out. And I have 2x and plus 2x squared, all over the x squared plus 1 squared. So then what we could do is we could, again, like a slope that we need, we could plug in. Oh, I'm sorry, I made a mistake, didn't I? This wasn't, oh,
That's part of the G.
Thank you. I was like, what did I do? Yeah, I was writing that was g squared. It's not x squared. My bad. So it's really 2x and 2x, which is 4x. My g squared got in the way. I was like, I knew this one was supposed to be like, the numerator was supposed to be something, one term. So anyways, 2x cubes canceled. I have 2x and a 2x, and that's 4x. Let's see, so thoughts there on the first example of quotient rule? Very similar to product rule. Basically, it's almost the same as product rule, just has a bottom. By the way, the bottom is always g squared, not g prime squared. Sometimes students do the way there. Okay, I wanted to show you one other thing about quotient rule, and then I will do one tangent line to finish up. So what I say here is I have y equals 3 over x as my function. In some simple cases like this, where it's not like x squared plus 1 at the bottom, something like that, I can do quotient rule, because it's a quotient. It's a fraction. Yeah. So I said, yes, quotient rule would work. I can also do the power rule. Sorry, that's supposed to say, or did I change this? It's supposed to say I can do the power rule. I changed it here. So quotient rule would work on this one, but I want to show you how we could use the power rule. So yes, you could do g f prime minus f g prime, all that. However, here's another way to do this one, using the power rule. This is x to the first power, right, on bottom. We were talking yesterday about negative exponents. I can change this, I can leave the 3 alone, but I can change this and take it to the numerator as a negative exponent. So I can make it x to the negative 1 power, now it's in the numerator, and there's no denominator. So now I can just use the power rule. So yeah, let's see. So y prime, I bring down the negative 1. Well, I really bring down the 3, because that's in front. Then I can bring down the negative 1 and multiply those. So it's negative 3. X, and then I subtract 1 from negative 1, it's negative 2. And that is the derivative. I'll change it so there's no negative exponents. So I keep the negative 3, and this is over 1. And then I put this down in the denominator as x to the positive 2. So on those guys, if you're like, well, I didn't like that as much, fine, just do, you can always do quotient rule. But sometimes it can be a lot faster to just move this up as a negative exponent, do the power rule. It can be shorter. And you get the same result. So I just want to show you that. Now that wouldn't work when it's something like up here, x squared plus 1. Usually it has to be just x on the bottom, or just x squared or x cubed on the bottom, something simple. So for example, this one, there is a way, but we don't know how to do it yet. That one can't really do what the rule I was just talking about, because that's a 2 in front. In the future we can. All right, can I do the last one? Any thoughts on this one? No? So find the equation of the tangent line for this curve. Right, so again, what's great about this is whatever this curve looks like, at 1, so great, we can find the slope of right there at that point, and what we're doing is find the tangent line equation. Find the equation of that line. Okay, so first thing is I want to review that you have to plug in 1 twice. You plug it in to the original function to get your point for your tangent line. And then once we get the derivative, you'll plug in 1 again to get the slope. So let's go ahead and plug it in now. Then I'll get my y coordinate. So 1 squared is 1 plus 3 is 4 over 2. So the y coordinate is 2. So that'll be my x and y I need, whether I use slope intercept or point slope. Okay, next thing I'm going to do is, because tangent line, I need the slope. And to get that, that's derivative. Good. So now I need to do the derivative, and then I will again plug in 1. So I'm just going to repeat before. It's gf prime, where this is g. So it's gf prime, low d high. So I put the low, the g. F prime is derivative of x squared is 2x. Derivative of 3 is 0. So that was low d high minus high, x squared plus 3. And d low, derivative of the low, is 2. And derivative of 2x is 2. Gf prime minus f g prime. All over the low square. So all over 2x squared. Just simplify the numerator a little bit, and then we'll plug in our x value of 1 to get the slope. Alright, so right here we can get multiply these, get 4x squared. Here again I'm going to multiply the 2, and I'm going to keep the negative out front for now. So it's 2x squared plus 6. The bottom, yeah, I can go ahead and square that. Yeah, you can leave it as is if you want to, but 2 squared is 4, and x squared is x squared. All right, really to finish up this one, let me go ahead and distribute the negative. So that's negative, and this is now negative. And so 4x squared minus 2x squared is 2x squared, and then I have a minus 6. All over 4x squared. And that's really as much as I'm going to be able to simplify. Okay. So there are other ways to make different fractions, but this is the most compact way. I get the derivative. All I'm going to do now is find the slope at 1. Because this is my equation that represents the slope. So I just plug in 1 here. 1 squared 1 times 2 is 2. So it's 2 minus 6, which is negative 4. And then down here, 1 squared is 1 times 4 is 4. And so my slope is negative 1. All right, and then with that information, I'll do slope intercept. Sometimes I do point slope. Whichever one you like is fine. So I use that slope of negative 1. Put it in here. If it said normal line, I would have done perpendicular slope. What was my x was 1. My y was 2. Okay, so negative 1 times 1 is negative 1. I add 1, so we get b is 3. And so my final equation is y equals negative 1x. And then plus 3. So there's a nice example with tangent line. You can see where we would use the quotient rule. Don't forget though, you do have to plug in 1 originally as well, just to get your y coordinate. Did that first. Then do the derivative, plug in 1, that will give you your slope, and then you just write the equation. Okay, anything I can clarify about derivative rules? Yes?
What happened to the 4x on top? The 4x squared?
4, I combined with, it was 4x squared, and then I distributed this, and so it was negative 2x squared minus 6. And so those just became the 2x squared.
Okay.
Combined like terms. Yeah. Hey, another thing I just thought of, technically, once you get this, you can plug in 1 if you want, right, to all of these, to get your slope. The only reason I didn't is because it's normally what do we do? We simplify as much as we can, then plug in. But you really could have plugged in 1 earlier. Good thought. Any other questions I can answer?